Good to see you all. Nearly the last talk, but there's still quite some people. I'm very happy with that. So today I will be talking about WebAssembly and what kind of architectures we can build with that. But before that, I would like my clicker to work. Clicker, 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 yeah. Yes, got it. All right, so first I would like to talk a bit about cloud native, because it's a term that's not very well defined. It just kind of happened, right? Like something that's really good at cloud. And I tried to find a really clear definition, didn't really. And generally what people think about cloud native, then they think something with Kubernetes and containers and things and microservices. And so is Kubernetes cloud native? Well, apparently. So what does Kubernetes do? Kubernetes runs containers and just do some magic, but the thing it does is running containers. So is a container cloud native? I guess, but if we look on the outside, it's very, very cloud native. But if we look on the inside, and we just run a simple container, and we look inside, there's all kind of weird stuff in there. So for example, there is a home directory for users, and there's a root for the root users. There are no users, like it's fake. There's a /dev, there are devices. There are not really devices. That computer doesn't really exist. It's like a ghost that thinks it still has a body. So the outside of the container is cloud native, the inside is not. In a way, like the inside container is a bit like a spacesuit for your application, because it's an application that's used to being on the ground, now it's in the cloud, it needs to be protected in some way. So then the next question would be, why do our applications need a space? Why aren't they cloud native? And that question goes back a really long time, for like decades, to an ancient API that's called POSIX. And it's basically unchanged for, I don't know, 40 years or something like that. And that's the API all applications use on the server, where you just do stuff with the operating system. You open files, you allocate memory, you spawn other processes, and you access networks. So it is pretty useful. Like you can't really say we're not going to do that anymore. But it is really everywhere. It doesn't matter which stack you use. Node.js, POSIX. Java, POSIX. Rust, POSIX. Everything uses POSIX. So that's a bit of a that's an interesting situation, because like if you run a command, like listing the directories in a file, this is all the things it can do. Right? What you wanted is to look at the file system, maybe allocate some memory, I'm not sure. But all that other stuff, that's not really what it's supposed to do. And in a sense, it's also a bit of a liability, because it could be uploading stuff to some sketchy site. I don't know, you have no way of telling. It has the same permissions as you have. So generally what you would like is that you can just pick and choose what stuff it needs to touch. I don't know if you spotted it, but memory management is in there twice. I had a long conversation with ChatGPT to get it out there. Didn't happen. So I guess it's in here. So that's a liability, right? So all the stuff that can do so many things, while it has no business of doing that, that's just, in terms of security, that's not great. Another problem we have, if we have an application with sensitive data, imagine what it is, I don't know, medical stuff, bank stuff, whatever. We have different users doing their thing, but they all talk to the same memory space, right? Making sure that this user doesn't see data from that user is up to the application developer to not mess it up. If you have a low-level language like C, it is kind of tricky, because like you end up having a lot of, you have to get all the memory allocation, everything right. If you have a higher level memory managed language, it's a little bit easier, but still, right? It is there is no protection between different users. So all in all, I think this means that we are not cloud native yet. So moving forward from this, let's have a talk about WebAssembly, and I think how it can help. So let's have a small history of WebAssembly. Anyone worked with WebAssembly? One, maybe two, I'm not sure. So I'll start at the beginning. So long time ago, 2012, there was a desire to run more high-performance things in browsers. And as most people know, for like really geometry stuff or high mathematical stuff, JavaScript is not the quickest. So that tends to be slow. And what SMJS was, that if you take a subset of JavaScript, you just promise to do not to do certain things, you have a subset, and then it can go a whole lot faster. So for example, like that if you have a vector or array, that all the types need to be the same. In JavaScript, you can do whatever you want, but that costs a lot of time. So SMJS, standard. A few years later, there was an official standard called WebAssembly that kind of codified the idea from SMJS. And then you had, miraculously, in my opinion, that all the browsers more or less got on board and agreed on what WebAssembly apparently is. So that went pretty well. And what WebAssembly is generally a compilation target. So nobody in their right mind will write manual WebAssembly, but you will generally use a language to compile to it, and generally a lower level language, C, C++, Rust, TinyGo, some more, and hopefully later we can do all languages. There are some famous examples that use it, like Photoshop is a big one that had a big desktop application written in C++. They wanted in the browser. So what they did, they basically compiled their existing application to a new target, and then it could work in the browser, which is really cool. But that is only a thing if you have a big legacy C++ application or something like that. DuckDB is an analytics database, and it is really nice because you can just point at the data source on the internet and run the analytics locally, and it's a really nice way to, for example, share certain insights on the database because it's just a web link, right? Some web games, Unreal kind of works in WebAssembly, WebGL, that's the standard to use hardware-accelerated data. So I'm not going to talk about any of that because I'm a backend engineer, and anything I make is ugly anyway. So I will make backend stuff. And I'm going to talk about some extensions that WebAssembly needed to thrive on the server side, because technically you can run something on a server, but it was only aimed at doing stuff on the screen, so how's that going to work? And also, servers need access to stuff, because otherwise, what is it supposed to do? So first of all, you have the WebAssembly component model. That's an addition to WebAssembly where you kind of create different components that import and export different functionality, because otherwise you'll have to take all your code and just smoosh it together to one big binary, and we have learned on the back end that that's not great. So that's one reason. The second thing we have here is the WebAssembly system interface, also called WASI, and that's a way to talk to the operating system, because on the server you got to. If you don't have access to the operating system at all, are you even running? It's kind of like a philosophical question at that point. So the first version of that was a P1, the first preview, that basically copied POSIX, something that's similar. And that's really easy, because now it's a lot easier to port something to compile to WebAssembly, because basically you can use the standard library, and that's kind of the same life you have as a native binary. But that does introduce the stuff I talked about before with the cloud nativeness, that you don't want your server-side software to be able to do anything. right? We do a lot of effort to make sure it doesn't do everything. So there's a new preview just last year, and that's a componentized version of WASI. So you can pick and choose what kind of requirements you have from the operating system. There will be a P3 this year, famous last words, but there will be. And what that will introduce, first of all, support for asynchronous programming. It kind of has it now, but now it's really hard to work with. But there will be a more native one. And also there will be support for garbage collection that will open up the doors to use garbage collected languages. Right now you technically can do that, but that kind of means that you have to take your own garbage collector with you inside WebAssembly. So that will make the WebAssembly module really big, and that's not that ergonomic. And hopefully in 26 there will be a stable version, because there's not a lot of stable versions in this talk. Like it's all 0 point something. All right, so in conclusion, for the WebAssembly, high performance, because the only reason it exists is the existing stuff wasn't fast enough. It's built to run untrusted code. A web browser is one of the most hostile environments for software, because you really don't want different browser tabs to snoop into each other's data. So it is really well sandboxed. And it's also lightweight. Like you want all the modules you run in a browser to really be small. If you start something in a browser and it first needs to download 100 megabytes, that's not how web is supposed to be, right? So let's have a talk about microservices. This is like a typical microservice thing. It's an example I got from Quarkus. It's like about heroes and villains, and they can fight. But doesn't really matter. So what happens here is we have a client, talks to a service that can perform the fights, has its own database over HTTP, and there are some back-end services, and we'll call out to that, and they have their own database, and they do their thing. So if we zoom in a little bit, it looks something like that, right? We have a service. We have a runtime with a HTTP endpoint, and we have a database. The database isn't really inside the service, but close enough, right? So then enter the WebAssembly component model. So right now we're going to use it first for the new WASI. So we're going to define what a component needs to do its job and to what it needs to expose. And for that, because I didn't really mention, but WebAssembly is polyglot. It's not tied to a language. It's a compilation target. And anything you can compile to that, you don't care anymore from which language it came. So, because it's polyglot, you need to have a unified way to define what a component even is. And we do that in another format, and it's called WIT, WebAssembly Interface Types, I think. Looks something like this, and if you look at it, you can kind of figure out what it does. There's a package with a namespace, a component, and there's a world, and the world is kind of from a component's point of view. Like, what's the horizon? If you're inside the component looking out, what do you see? Well, what do you see? You see an import of Postgres, because you want to have access to accessing a relational database. You import as well the incoming handler, and you export that also. So, because you want other people to call you with your request. So, if we look at code, I'm not sure if it's too small. It's a piece of Rust, and in the end, it is a very familiar kind of model. If you remove all the unfamiliar things, there's a handle function with a request and a reply, and you do stuff, and then you're good. So this is what you want to expose to the world, and what it in the end does, it is called query from the database, and it creates some types, and it returns that. So there is nothing too fancy. But what's important to realize that this code has no access to, for example, the file system. even more, it doesn't even know what the file system is, in a sense. Like, if you have normal permissioned things, then you can write code that opens a file. It will just fail at runtime. Or there is some other security measure downstream that will stop it. But here, you can see it in your editor, right? I can't make it compile that open file without adding the import. So that's valuable in itself. So another thing to realize is that this is a scale to zero kind of thing. This is not a thing that runs all the time. What it exports is a function. A function gets called, and then it gets this component gets instantiated, gets its own memory space, until at the end of the handle function, it discards entire memory space. There is no way for two requests to ever meet, except maybe in the database at some point, I'm not sure, but these two are quite separated. Final thing to talk about this is that it kind of looks like I'm including a driver or something, but that's not quite it. I just give it access to functions to call it. The actual Postgres drive, because it must be somewhere, right, is outside the component. So if I want to update the driver, I don't need to touch my component. I just need to update it to a new compatible version that will have that access. So that's actually quite an important difference. We all know, like, with all the dependencies we have, with all the drivers, if there is a vulnerability there, then all of a sudden the whole world needs to recompile all their stuff. And the more you can get outside of your component, the better. So where were we? Oh yeah, the microservices. So what we can do, these 4 microservices, well, at least the 3 on the right, we kind of covered that one. This one, the fights one, needs to have a little bit more access because it needs to make HTTP calls as well. So then we need to add one more line, import outgoing handler, and then we have access to calling HTTP. Again, if you don't do it, you can't. So that makes it really kind of clear what you can do. I also added logging, so you can write logs, because also, if you don't do that, you can't do it. So now we have all of them, and we can convert all of them to WebAssembly if we want, and that will give us some nice security improvements, like that all the requests are strictly separated. It's also nice because it scales to 0, right? There's not a big runtime just sitting around waiting for something to happen. But we can do more than this, because we can ask ourselves, why even do all those internal HTTP calls? Because even if it's quick on a human scale, you have a nearby and you do a HTTP call and it's 1 millisecond or something like that. In computer terms, it is really long. Like doing HTTP calls is like traveling to the moon. If you have a local call, it is microseconds. And if you have a local network, it's milliseconds at best. Right? You waste a lot of time with that kind of stuff. Also because if you have data going in, going out, it has to go all the way through the stack. So you have to call the network stack, you have to encode your request, you have to JSON encode or gRPC or something like that, your data, and then you have to pump it through the line, and on the other side you have to go all the way back, and then you have to reply, and you do all the way back, all the way back, all the way back. And that's a lot of work. In many systems, I'm sure it's kind of hard to prove. Like, the actual work that systems do is a tiny fraction of all the shoving around data work. So can we remove those network gaps? Well, we could, because we can also expose specific functions, so not like HTTP, but the function we actually want to use. So for example, here, I've added an interface, hero repository, that will give access. First, we need to define what a hero is. It's like a record here, struct, class, whatever. And you have some functions that you're going to export. Now, we extend this, world of this component to export this repository, and we can remove all the HTTP stuff. So now, if somebody uses this component, you can just call get hero and you get a hero back. And then it doesn't need to go through JSON encoding and all the stuff. It will just have block memory copies. They're really fast. So that will be much quicker. Is it still a microservice then? I don't know. Like right now, we kind of define microservices as being separated by a network. And do we need that really? I kind of doubt it. I think if you add the new separations of components and of security to the stack, I think you may argue that you don't need to. And also in the sense of just being efficient with your code, these are really expensive. You can really make so much more efficient code. So that's an open question, but it does kind of see how you can get there in the microservice. Another thing, if we're talking about shoving data around, and that's the concept of data gravity, that data is fundamentally hard to move. If you have a lot of data and you want to move it somewhere else, it's possible, but it takes time, both in terms of throughput, like how quickly you can move something big, but also just latency, like the round trip. So what that usually comes down to is that we want to move the code to the data instead of the data to the code, because code is also data, but generally smaller. So what would that kind of look like? If we have an application like this, and we have a client that wants to analyze something, right? And you have a service, and you query the database. The database has a bunch of data in it. It will download all of it. I try to make the arrow fat, so you can see it's a lot of data instead of a little. And then it looks at all the data, and then it says, oh yeah, the total is 5, right? It can be a really small answer with a lot of data. Now, what we would like to do is move the analyze from here to there, right? So that we don't need to do the whole downloading stuff. Now, that's something WebAssembly can be helpful with, right? Because you can make an API where you can upload basically a WebAssembly module that has exactly those permissions. You can export exactly what kind of, in your service, what kind of access you want to give to that component. It can do its thing, it returns some value, and you download that. So we kind of killed one fat arrow. There is still that one, because we still download everything out of the database. So can we go even further with this? Oh yeah, so yeah, this is a very nice case for WebAssembly, right? Because we have, it's now the other way around in the sense that like without something like WebAssembly, good luck convincing that service to run your code, right? It would be a very sketchy thing. So that helps, the lightweight helps, and the high performance, of course, as well. So from here, how can we remove that last fat arrow? Well, we can just move it here. And that sounds like a really sketchy proposition. Anyone who ever worked with stored procedures, because that's basically what we end up doing. Yeah, I feel your pain, I've been there. But on the other hand, we should not be making our life choices just based on trauma, right? Maybe we just did it wrong. And there is, well, first of all, right now, this service is a little bit silly now, it doesn't do anything, so let's remove that. So we have a client, and we have a database servery thing that does everything else. There are some nice ones out there. Have anybody heard of Spacetime DB? I thought not. It is a little bit on the fringe of databases, but it is really cool, and it's getting some interesting traction. It's actually a backend for multiplayer. So it is meant to be a complete backend along with data for multiplayer clients to connect to and synchronize their world views in a sense. But it is a very interesting way of changing the perspective of how our systems work. Because generally when we use a system, we kind of think about, I am here and I'm shoving data in and out of that system, the system is there. But if you kind of think about, okay, I'm inside the system, just as all the other users, what can I see, what can I do? I kind of like the mind shift of that all. So I've been following it for a while. It went 1.0 a few months ago. The programming model, it supports C# and Rust for now. C# because it is really, it wants to support Unity, which is a game engine, and Rust because it's written in Rust. And you can create modules on the server that compile to WebAssembly. And you can upload them to the server, and they will deal with the data really close to the data. The latency between a module and the data is really microseconds now, right? So all the data, all your code, you need to compile to WebAssembly, but you still have it's still ACID compliant. And that's not that expensive because the price of consistency generally grows with distance. If you can do it all very close to the data, it's not the biggest deal. I ported the demo before to it, and that was actually surprisingly smooth. It does require you some rethinking of what makes sense in an application. And I'm not saying that this is the be-all and end-all, but it is kind of nice to be challenged on the fundamentals. Like, do we want to do it like that? Also, what I think is cool, they're writing a big MMO game, and they're using this as a background. They're writing it at the same time. So I really like that model, because if you write the game first and then try to extract the database out of it, it always gets messy. And if you just write the database because you think somebody will like it, then you might have a mismatch also that is actually not usable. Now you kind of know. So, wrapping up a little bit, but I'm not quite there yet. There are some interesting things on the server. The one I showed first, the microservice was wasmCloud, which is a really nice crew of people. Fermion Spin is also quite well known, and it's a bit easier to use, but quite performant as well. Also, and just the fact that you have like the scale to 0 and you spin up in a millisecond is really useful for like low traffic sites. Like if you have a site that gets, I don't know, like 1 request a day. If you do it in Java, you have a JVM that sits around 24/7 just waiting. And if you can scale to 0, it's a lot cheaper. In streaming data, a Red Panda, that's a Kafka rewrite. And there you can introduce WebAssembly modules to topics in a sense. So you can say like, before inserting a message in this topic, run it through this. So you can, for example, use it to remove sensitive data or to make sure there's nothing weird in there. And because it's really close to the data, it is a lot easier to work with. Stream processing, Infineon Fluvio is kind of like Flink, Apache Flink, stateful stream processing, which is, for example, if you want to have a running total out of a stream of events, like it's very, very close to the last talk in that sense, that you have a stream of changes. You want to have a real-time view on where are we now. That's really nice with Fluvio. Backend as a server, the Spacetime DB, we talked about that. And also CDNs, Fastly, is very big in WebAssembly. For example, that you can create your own access rules for certain web assets or inside your CDN. And you can move some intelligence toward the user, but not at the user, because if you make it client-side, it's not reliable anymore, because who knows what clients do, but you kind of get it as close as possible where you still control it. All right. There are indeed some challenges. It is not mainstream, very much so. I kind of like it. I kind of like that kind of pain, but you will find stuff that doesn't work or just works weirdly all the time. And that's no dig of that. That's just how new stuff works. Debugging is also tricky. And also, if you think about it, aside from the technicalities, if you have a system of different components that all wire together, but they're all written in different languages, how would that even work, right? So somehow all the language stacks and build pipeline need to align on how that would work. So right now it's not quite there yet, but on the other hand, there is no reason it cannot be, right? It is possible, but it requires a lot of synchronization. And indeed, the polyglot programming model adds some complexity in the sense that, like, the component definitions, they have their own language, but they don't really fit nicely with all the language ecosystem. They're all a little bit different. Like, what works for Rust it feels off in Go, etc. So you'll always have some kind of. It is not as comfortable when you do, we only do Java or we only do Rust. But what I do like is that it makes you think. It makes you think about what we should change now. Because if you just take a system and you sprinkle some WebAssembly on it, it's not going to be amazing all of a sudden. That's not how anything works. But it does allow you to move forward. Yeah, so in my opinion, the value is often in what you don't need to do anymore. So like the network hops I said before, if you can, WebAssembly enables that you can safely do that. But if you don't do that, you're just adding a layer to the big thing, right? But that does require you to question things that we never thought about before. Did I ever think about, should we use POSIX in the next process? No, because of course, what else is there? Well, now there is something, and now it's a valid discussion point. Yeah, and there are so many things that we don't really think about anymore. So, yeah, I think if we take that all into consideration, I think if we can make our applications cloud native without the spacesuit, right? So that we're really cloud native. One more thing, don't forget to rate the talk. And also, I'm not sure, should I have been more technical or more high level? I tried to be technical, but there was a lot of high-level stuff that I thought I needed to explain. So we are where we are, but let me know, I'm interested, because, like, yeah, I want to do it again. And also, I created a link with some stuff that's out there, some repositories that has some code in it, if you're interested. And that's all for me for now.
All right, so we have some questions, actually. I hope you have some time. I mean, you are more than in time. So let's start from the top. We have Juan Manuel Nayar, and just correct me if I'm focusing wrong the question, because I'm not totally sure I understood all of it. But it's having languages that could interact with POSIX, how can we ensure the compilation to WASM limits the access to some resources?
Well, it's mostly up to the WASM runtime. So the WASM runtime is a native process that will start the WebAssembly process, and it will only give access to what's there. And if you get the compilation wrong, it will crash there. So unless the WebAssembly runtime really, really messes up, that should be okay.
All right. We have another one, also from Juan Manuel. Juan Manuel is a fan. How can WebAssembly exports in the cloud be consumed other than browsers?
Can you repeat?
How can WebAssembly exports in the cloud be consumed?
Okay. Well, at some point, your WebAssembly world ends, and then you need something else, right? So right now, I use the incoming and outgoing HTTP, but there's also like a messaging API, so you can hook that up to Kafka or Nets or something like that. So this is not meant to go over a wire. This is local. So you need to add something to cross the internet.
All right. And one last question from Borja. Borja asks, can separate teams evolve microservices independently with the new WebAssembly approach that can skip the network overload?
Yes. Yeah. You can just you can basically replace you can redeploy the services on this is in wasmCloud, in the wasmCloud cluster, and the fact that they are not actual different processes on different machines doesn't matter. It kind of just feels like updating a Kubernetes pod.
Awesome. I think that was the last question. So very big applause for Frank.
Thank you.